midpoint of a side to the opposite vertex. That's going to be a really big vocab word today. So if we draw out a triangle, you can draw any type of triangle you want. I'm going to just do that one. We'll just call it ABC. I'm going to start by making a midpoint on one of the sides. Doesn't matter which one I'm going to start with. We're just going to draw on one median. So I'm going to pick the midpoint of AC. So I'm going to try and find the middle of that without being too crazy. So there's my midpoint. How can I show to my reader that that's the middle?
How could we mark that side, that A to C here, this side? How could we mark that up to show that this point is exactly in the middle? We know something's in the middle. What do we know about the two sides? They're equal. And in geometry, how do we mark something that we know is the same or equal? With the little line. Yeah.
So this side is the same as this side. So now we know it's in the middle. Now what I'm going to do is connect it to the opposite vertex. And the vertex, remember, is like the corners, the angles of the triangle. So do I want to connect this to A, B, or C? What would be opposite of that point? Yeah, B. It has to go across the triangle. So it's going to end up going to B. And that is our median. Alright, Miss Snyder is going to be handing out a little sheet. You don't have to cut it apart. I think you should just be able to glue it in. If you want to cut it apart because you are fancy like that, I guess you could. But I would just glue it in as it is. So right underneath that, I would glue it on the left side. Alright, when you put the glue down, please make sure you're getting that all the way down before you put it on. Don't smush the top on. It's going to help us keep it a little bit longer. Alright, so go ahead and get that glued in. Alright, so in this triangle here, we know that point V is the centroid, is what we call it. So V is the centroid. of what's that overall triangle? What would be the three vertices of that triangle? QPR? Yep. Triangle QPR. Or you could do QRP, or RPQ, RQP, PQR, or PRQ. So many options. Alright, what a centroid means is a couple of things. First off, it is the center of mass, which is why we call it the centroid, and we use that word center instead of the, I suppose we've been using center the whole time, never mind. But centroid is the center of mass, so when we cut out that triangle on the cardboard, if you were here the first day, we cut out a triangle on cardboard and we tried to balance it on the tip of a pencil. And you could do that if you found the centroid exactly. Now, the cardboard, it depended on if you bent your cardboard, didn't bend your cardboard. Some of the cardboard, I think, was thicker in different places. It wasn't perfect cardboard, but it was really cool. It worked for some of us, right? You guys remember that? Am I crazy? That was 3 days ago, right? All right. But it's the center of mass. It's also where the point where all the medians intersect. So S, U, and T are where those medians start. So SR is a median, TP, UQ. Okay. And a median means it is a midpoint. So T is a midpoint of QR, which means I can show that this side is the same as this side, because it's the midpoint. Okay, U is also a midpoint. How am I going to show that this side is congruent to this side? Yeah, 2 lines this time, because it's not the same as the other one, so it's different. So 2 lines, 2 lines. And then S is also a midpoint there, so we'll do 3 lines there. All right, this brings us to our centroid theorem, which helps us find different measurements, involving the centroid. And what the centroid theorem tells us is if I have a median, at one end of the median is going to be the midpoint. And what does a median connect? A midpoint to a what's on the other end?
Look back at that first definition.
A median connects the midpoint to a vertex. Yeah, vertex. All right, now what this theorem says is that that centroid is not in the center, it's not in the middle of this. What's going to happen is that centroid ends up being a little bit closer to that midpoint than it does the vertex. So right here would be that centroid. And it breaks it up into parts that we're able to tell. So this first part is going to just be X. And whatever that is, the next part doubles it. So it's going to be 2x.
So it's like if we took that line and we divided it into 3 parts. One of the parts would be the midpoint to the centroid. And then the other 2 parts would be the centroid to the vertex.
All right, so we are going to be doing a couple examples. We're going to go to this triangle down here. We have 3 examples we're going to do with this one. Okay, in all those examples, we know that Q is the centroid of triangle JKL. All right. So for problem number 1, we know that QN equals 6. I want to know what is QJ and what is JN. So the first thing I would do is realize where is that in my triangle? What median am I looking at? So I'm going to look for Q to N. And Q to N is this part here. So really I'm looking at this midpoint from J all the way to N, that median, not midpoint, sorry. I get those two confused in my brain a lot. Okay, I'm going to draw that over here just a little bit, kind of in the same idea. I have N and J. Is Q a little bit closer to J or is Q a little bit closer to N? Yeah, closer to N. I'm going to highlight that to show that's where we got that from, right here to here. All right, I know that QN is 6. So is this my part that is the X, or is this my part that's 2X? Is this the smaller part, or is this the part that's doubled? It's the smaller part. This is the X. So to get JQ, I need to do 2 times our X. So if our X is 6, what is 2 times our X going to be? 2 times 6, which is 12. So Q to J would be 12, right? And then our next one is asking us from J to N. So all the way from the beginning, all the way to the end. How much would that be? J all the way to N. 18. How'd you get 18? Yep, segment addition postulate. We add them together. Part plus a part equals the whole. 12 plus 6 is 18. Alright, we're going to do 2 more. Number 2, I'm going to write down here. We'll have to do number 3 probably off to the side here because I'm running a little bit out of space. Hi. Thank you. Alright, number 2. In this one, we know that ML is 36. I want to find out what is MQ and what is QL. I'm going to switch up highlighters, so if you want to switch highlighters with me, you can. So I have ML, M to L. So this time it's kind of working its way down in that diagonal. I always like to redraw it. Some people think I'm crazy. They're like, it's right there. Why are you redrawing it? I like to mark it up. So I have M and L. Oh, you guys can't see my drawing, but that's okay. We'll figure it out. There we go. Now the centroid is always going to be closer to the midpoint. So when I look at this picture, which one is the midpoint? M is the midpoint, or is L the midpoint? Yeah, M is the midpoint. It's on the side. So Q is going to be a little bit closer to M. So which part is going to be the x, and which part will be the 2x? MQ is going to be x, because it's a smaller part. And then QL will be 2x. Now we knew M to L. So the whole thing, M all the way to L, is 36. So I need to figure out how can I break up 36 into a number and a number times 2. Divide it, yeah. How many x's are there really here? I have a 2x and another x, so how many x's total would that be? 3. So I really have 3 x's together would make 36. I want to try and just find x by itself. How would I undo that multiplying by 3? Division, yeah, divide by 3. Which some people probably did this without writing the equation, and that's okay. We're going to get the same answer. So what is 36 divided by 3? 12. So which part is going to be 12? MQ or QL? Is this what x equals, or is it what 2 equals? X equals. And which part did we say is x? MQ. So MQ is that x. So MQ is 12. And then there's a couple ways we can find that 2x. 24. How did you get 24, Hubert? 12 plus 24 is 36. Good, so thinking that together they have to make 36, so 12 plus 24 makes 36. How else could we have gotten that 24? Yeah, times 2. It's 2 times x, so 12 times 2 is 24. Or I could subtract 36 minus 12, 24. All the same thing. Ay, my computer is going to die. All right, we have one more example, and then you guys have the rest of the time to work today. Try to keep notes a little bit shorter today. We know we've been keeping you a long time on them. All right, so this is example 3. I'm going to just write it off to the side over here, so that because we're still using that same triangle. All right, number 3. All right, number 3, we know that QK equals 16. I want to know what is PQ and what is KP. Alright, so first thing we're going to do is locate where is KQ? QK. My goodness, I cannot say that in the right order. QK is Q to K. So we're going to be looking at this median that kind of goes almost straight up and down there. I always like to redraw that median, so even on your practice work today, if you ask me for help, the first thing I'm going to do is grab a whiteboard and I'm going to redraw that median that we're looking at, because it helps me to really focus on which part we're looking at. So at the bottom we have P. At the top we have K. Is the centroid Q, is the centroid going to be closer to the vertex K? Or is the centroid closer to the midpoint P? Yeah, the centroid is always closer to that midpoint, just by a little bit. So Q is going to be a little bit closer to that P. This time, I know QK is 16. So Q to K is 16. Is 16 my X, or is 16 my 2X? Yeah, the 2X part. So if that's double my X, and I need to go back down to the smaller part, as I move up, I'd be multiplying by 2. How do I go backwards? Not subtract. What's the opposite of multiply? Divide. We're going to split it up. So if double X is 16, what would just X be? 8. So PQ is 8. If you need to write that down, that we divided by 2, you can write that down. If you're like, yep, got it, don't write that down. It's your notes. All right, and then how am I going to find the whole thing, K to P? Good, 16 plus 8, and we get 24. Nice. You guys crushed that. Way to go. All right, that is it for your notes today. So I wanted to make sure we give you a little bit more time. Now would be a good time to get caught up on any of your other practice. Today's practice is a little bit shorter. It's 5 questions. It's going to be a lot like the practice we just did here.
So even though we're on 5G,